The point -4, 3 is a terminal point of angle theta in standard position. So first of all of these questions that start this way, 1, 2, 3, 4 to the left, 1, 2, 3 up. There's the point -4, 3. And if that's a point on the terminal arm, this is the angle theta in standard position. But anytime we can draw a picture like this, we can always make a triangle with the nearest x-axis. So I'm going to go down here, make a right angle triangle, label my reference angle in there. And I know this length of this side is 4. I know the length of this side is 3. This is a very famous triangle because a squared plus b squared equals c squared. Do the mental math. What's the other side? 5. Famous 3, 4, 5 triangle. So that point, we've drawn the picture. We need to find the possible values of theta in the domain from -2 pi to 2 pi. So first, we're going to find the reference angle. In trigonometry, finding the reference angle is super important. It'll be the thing that we always try to do first. And based on this triangle, I would know, I could do sine, cos, or tan. I would probably choose tan. Tan of my reference angle is 3/4. Tan of theta would be negative in quadrant 2. But we always use positive values with the reference angle because we're thinking of the actual triangle. So then I can go to my calculator and I can go tan inverse of 3 divided by 4. And I get 0.6435. Sometimes when I'm doing my math, I'll put like 3 dots there to say, I'm not rounding early. I'm going to keep all my decimal places till the very end. Okay, at the very end, I read in this question, it wants the nearest tenth, so I'll round at the very end. So now we want to find theta, what theta would equal. And we're looking for theta in this domain. When the domain has positives and negatives, standard position always starts at 0. So when the domain goes from -2 pi to 2 pi, I actually break it up and I say, okay, I'm looking for a positive angle from 0 to 2 pi and a negative angle from 0 to -2 pi. I'll show that negative angle in red here, right? That would be another possibility. So considering that, how would I do this angle? Well, in degrees, we would have gone 180 minus our reference angle. But now we're in radians. So let's just write out in radians. This is still 0 in radians, right? All the way around in radians is 2 pi. Halfway around in radians would be pi. Pi radians is equal to 180 degrees. So if in degrees you would have went 180 degrees minus my reference angle, does it make sense that in radians, this answer will be pi minus my reference angle? So I'm going to go to my calculator. Pi minus my reference angle. and I get 2.498 to the nearest tenth would be 2.5. Can you see in the negative direction that halfway around would be pi, and then I could add my reference angle, and whatever answer I get when I do that, because I'm going in the negative direction, I'll just put a negative in front of it. So in the negative direction, I'm going to figure out what pi plus my reference angle is, and I get negative 3.8. Part B here, we're given cotangent of theta equals negative 2. Anytime you're giving one of the reciprocal functions, you can write the one that corresponds to it. Notice here the angle doesn't change, but the ratio is the reciprocal. So cotangent of theta is equal to negative 2, then tangent of theta is equal to negative 1 over 2. And if tangent of theta is equal to 1 over 2, according to our cast rule, tangent is negative in quadrant 2 and quadrant 4. We always start by finding our reference angle first. And our reference angle will equal, right? I have tan, so I want to do tan inverse. Very important here, though. For finding our reference angle's always in quadrant 1. We always use positive values. So even though tan of theta was negative 1/2, when finding our reference angle, we go tan inverse of positive 1/2. And typing that into our calculator, I get 0.4636 ... I'm going to show you some things that are kind of neat with your calculator, so I'm going to actually retype this into our calculator. So tan inverse. Second, tan inverse of 1 divided by 2. 0.4634. Now, if you have a graphing calculator, you can take this value, because we're going to use it a lot, and above the on button is a store button. So I'm going to temporarily store it as X. This is going to be helpful for us, because if we want to find what the angles are, and our answers are going to be in quadrant 2, there's an answer, and in quadrant 4, there's an answer. This will be my positive answer in quadrant 2. This will be my positive answer in quadrant 4. And just like the first question, the domain on this second one is exactly the same idea here. We're looking for positive angles from 0 to 2 pi and negative angles from 0 to negative 2 pi. So what's this one going to be? Well, here's my reference angle. Does it make sense that this one is going to equal all the way around pi minus my reference angle? Just because like you would do 180 minus your reference angle, now that we're in radians, we'll do pi minus our reference angle. And this one here Normally, if this is your reference angle right here, you would do 360 degrees minus your reference angle. But now that we're in radians, all the way around is 2 pi minus our reference angle. So I'm going to go to my calculator and write these answers. Theta equals. The first one was pi minus my reference angle. And since I stored my answer as x, I can just hit the x button instead of having to retype all of those decimal places. You have an answer button on your calculator too, that works out nice. But the nice thing about storing it as x is now my second one was 2 pi minus my reference angle. I can do that one quickly as well. And this question asked us to round to the nearest tenth, so that'll be 2.7 and 5.8.
Don't we have to do the negative ones too?
We have to do the negative ones as well. So I'm going to do those in red. Here's one negative answer, and here's the second negative answer. The first negative answer, can you see that if you did pi plus your reference angle, that would be the angle, and you'd have to make it negative. So I'll go to my calculator again. Maybe. So I go pi plus, and I've saved it as x, 3.6. So I'll write this as negative 3.6, because here this will be pi plus my reference angle, but then it's going in the negative direction, so I add a negative after. And the second one is exactly equal to my reference angle. So I don't have to do any math here. My reference angle is 0.5, but it's negative, so I'd write negative 0.5. Because I rounded the 0.46 to the nearest 10.
Oh.
These are very typical questions, and they're hard because they involve so much knowledge. If we're solving this equation, what do you all have to know? You have to know how reciprocal of cotangent works. You have to know your cast rule to say where it is. You have to know how angles in standard position work, both in the positive direction and the negative direction. You have to know how to find a reference angle. And you have to know how to use that reference angle to find the actual angles. These always come up. There's always these questions on the exam. It's probably the most typical kind of question that you get. Some sort of solving with trigonometry, and there's lots of stuff involved. So I don't know if you want to put a star beside this one. Super important. Circle questions 13 and 14.